Hello friends, we are looking a variety of keys which is used in the database management system. That is, that is a super key. Second one is candidate key. Third one is a primary key. And fourth one is secondary key or alternative key. Let's take one relations A, B, C along with functional dependency set which consists of A tends to B, P tends to C. So everybody know that a relation is a table. A, P, C are the attributes which describe the properties of the tables. Functional dependency set which consists of collection of functional dependency. Generally, functional dependency will be denoted S tends to Y. It is a constraint between two set of attributes. It is a constraint between two set of attributes. X is a set of attributes, and Y is a set of attributes. Generally, this set of attributes is always greater than or equal to 1. Greater than or equal to 1. So, what is mean that? Which means, if somebody gives the x values, I can easily find y value uniquely, which means x determine y, or y is functionally depend on x. That is the meaning. Mathematically we can define mathematical logic, we can define if d1 dot x equal to d2 dot x, then d1 dot y is equal to d2 dot y, which means whenever x value will be repeated in the particular attributes, then corresponding y values are the same. We can represent the diagrammatic also. The diagrammatic also we can represent for functional dependency diagram. This is the set of attributes x. This is a set of attributes y. In these two set of attributes, the relations will be a one-to-one relations or many-to-one relations. This is the functional dependency. And note that x is a set of attributes and y is a set of attributes. One to many relation is not possible for functional dependency s tends to y. Y is not possible because if somebody give the x values, I can find y value uniquely, but here y values are two corresponding x values. Therefore, one to many is a relations, but not your functions. Now we got idea about what is functional dependency. But the question is, where it is applied. Where it is applied. Actually, generally, functional dependency is a encoding form of business logic. Example, core type is a attributes will be determined. Car parking area, car parking area example is car type is a 4, and car parking area is a first class, that is the E class. Suppose a car type is ambassador, then the car parking area will be T grade, T class area, which means that the car type will be determined the car parking area, which means the car parking area is functionally dependent on the car type. This is the business logic. This business logic will be encoded in the form of the functional dependency. And also one of the biggest application of the functional dependency, nowadays we are creating Nowadays, we are creating database applications. Real-time data applications generally is a very, very complex. One of the challenging to create the real-time database application is design the databases. Design databases. In design databases, multiple bases are involved. The first base is the ER diagram, which are focusing on entity set, relationship set, attribute set. Later, this ER diagram will be converted into the relational model. This relational model will be focused on relations, that is the tables, primary key, foreign key, etc. Then finally, we are applying the normalizations. Sir, what is mean by the normalizations? So generally, the ultimate aim of normalization is to minimize the redundancy. To minimize the redundancy in a database. Sir, why we need or why we minimize redundancy in the database? If your database contain redundancy, what will happens? It will occupy more hard disk. Hard disk space will be more. And the second one is accessing time. Accessing time is a primary factor of databases. This is also high. In these reasons, we want to minimize the redundancy or remove the redundancy from the databases. Functional dependency. So functional dependency will play important role of normalization. Okay, cool. Now let's we move our topic, that is the key topic. The first one is a super key. The first one is super key. So what is mean by the super key? Generally key is a subset of attributes. Subset of attributes. So super key is nothing but, so it's a subset of attribute which uniquely determine each tuple in relation, or take the same relation which having A, B, Z attributes. What are the subset or possibles? So we are studying discrete mathematics. What are the subset or possible? The first subset is an empty set. Then second is A. Then third is B. Then C. Then AB. Then BC. Then CA. Then ABC. These are the subset of the given relation R which contain A, B, C or attributes. Now, what is mean by uniquely determined each double in relations? So, note that by is an empty set. Empty set never be a super key because super key contains at least one attributes. Empty set does not having any attributes. Therefore, empty set is never have a super key. Now we are checking A is a super key. Of course, A is a subset, but how to check? A is uniquely determined each double linear relation. Therefore, attribute closure will come into the picture. Take attribute closure of A. So the functional dependency of the given relations are A tends to B, B tends to C. So take attribute closure which A, comma B, comma C. Yes, attribute closure of A which determine all other attributes in the given relations are therefore A is a super key. B is a subset. How to check whether B is a super key or not? Take attribute closure of B. P closure will be determined P, comma C only. This set does not contain A. Then P never be a super key. And C, take the C closure. C closure only determines C. Therefore, C never be a super key. In this way, we are determine all the subset closure AB closure will be determined A, comma B, comma C. Yes, it is determined all the attributes. Therefore, AB is a super key. Therefore, AB is a super key as well as determine PZ plus will be determine P, comma C only. Therefore, PC is not a super key as well as find attribute closure of CA plus which C, comma A, comma B. Yes, this is a super key. Of course, A, B, C attribute closure definitely will find A, comma B, comma C. Therefore, this is a super key. So finally, we are find the super key set which consists of A, comma A, B, C. These are the super key set. Generally, super key is all set with number of super key of the given relation is always greater than or equal to 1 number of super key. Now we are moving the candidate key. So candidate key is a super key and attributes will be a minimal. Sir, what is mean by the minimal? Take all the super key like A, AB, ABC. A is a single attributes will be determined all other attributes A comma P comma C. Therefore, A is a super key as well as candidate key. Sir, how A is a candidate key? Because we cannot eliminate super key. We cannot eliminate single or more some attributes from the super key A. A is a single key. How can eliminate other attributes? Now we are checking A, P super key. If I want to eliminate P attribute, a single attribute A alone will be determined A comma P comma C. Therefore, AB is a super key and CK and AB is not a candidate key because AB is not a minimal, which means I removed P attribute. The remaining attribute A alone will be determine all other attribute in the given relation. Therefore, AB is not a candidate key. As well as I remove PC attribute. A attributes alone determine all other attributes. Therefore, A alone will be determined. Therefore, ABC is a super key. ABC is not a candidate key. Now we are finding the possible candidate key are A only. Generally, the number of candidate key of the given relations, the number of candidate key of the given relation is always a greater than or equal to 1. In this case, we have only one candidate key. And now we are moving the super key. Primary key. What is mean by the primary key? Generally, the number of candidate key is always greater than or equal to 1 of the given relations. In this case, candidate key is always a single. So we can pick A as a primary key by a database designer. A is a primary key as a database designer by a database designer. In most of the case, number of candidate keys always greater than or equal to 1. That case, one of the candidate key picked as a primary key by a database designer. It is a database designer choice. In this case, we have only one candidate key. Therefore, we are selecting or we are picking directly A as a primary key by a database designer. The number of primary key, the number of primary keys always exactly is equal to 1 per relations. And always primary keys will be a unique and not null. These are primary key constraints. Don't worry about this constraint by a database developer. This constraint take care by the database management systems. Now we are moving a secondary key or alternative key. These are the key which are not participated by in the primary key. Remaining all other candidate key except primary key or alternative key. In this case, there is no secondary key or alternative key, that is empty set. But in the real world, candidate key is having lot of candidate keys. Database designers select one of the candidate key as a primary key, and the remaining candidate key are acting at the secondary key or alternative key. Hope this video will be helpful for the beginner. Thank you so much.